Hey guys, this is Carrie, and this is the answer key for homework number 10. So draw exactly one cycle of each of these graphs. I'm going to be using radians, not degrees, and you should be at this point too. The directions are kind of old. So for sine of x starts at the midline, goes up, and completes a full cycle after returning to the midline from an up and then a down. So a couple of key values you want to include is the amplitude is 1, so we go up to a height of 1, and then since the amplitude is 1, we go down to a height of -1, and we have a full period here, which would be this starts to repeat afterwards, and sine starts to repeat when we start to, after completing one full circle, which would be 2 pi radians. Halfway through there would be pi radians, pi over 2, and 3 pi over 2. For cosine, we want to draw one cycle of this. The difference between the two is cosine starts at its maximum value of 1, and then 1, that was not what I meant to do, 1, 0, -1, 0, back to 1. So you've got a full cycle at 2 pi radians in the middle, pi over 2, and 3 pi over 2. Use the graphs above to determine the value of the following expression. So for sine of pi over 2, we go to our sine graph at pi over 2. And when we plug in pi over 2, the x value, into the x value, the y value is 1. So the output here is 1. Cosine of pi has output -1. Cosine of 3 pi over 2 has output 0. Sine of 3 pi over 2 has output -1. So it looks like in total we'll get -1 for this. Determine the equation of the wave shown below. So for this one, we've got a cosine graph. Because the period is still 2 pi, we know that we have no inside transformation, it's just x. And then lastly, the amplitude is 6, but it's not actually lastly. This cosine graph has the opposite orientation as the sort of canonical basic version of cosine. And because it's the opposite, we'll need to put a negative sign in front of it to reflect it so that it starts at its minimum instead of starting at its maximum. On the grid below, graph g of x equals sine 4x on the domain 0 to 2 pi. So I'm going to be rescaling as we have been doing. So this will be pi over 2. This will be another 90 pi. This will be another 90 degrees, 3 pi over 2. And this will be the final 90 degrees, 2 pi. Also put a 0. So 4 sine of x is going to go up 4, starting at 0, go up to 4, back to 0, down to 4, up to 2 pi. And now we've got our entire period of our trig function. Okay, so for this one, we've got 3 cosine x plus 2. So this one has a vertical transformation, which is going to translate our whole graph up 2 units. So you go up 2 units here. So now our midline is going to be shifted all the way up 2 units. And I'm going to take what Sam did in class, Sam Gonzalez, who did a nice job of teaching this. So she marked on her midline the key values. And now from here, with cosine, looking back at our original form, cosine should be starting at its maximum value. So we want to start at our maximum value, which, because we have an amplitude of 3, is going to be 3 units above our midline. So we start off at 5. We come down to 0, which is not actually 0, it's just our midline. Then we're going to go down 3 total. So down 3 from here would be back to -1, up from -1 to the midline, and then from the midline up back to the maximum, giving us a complete cycle of cosine. So y equals 3 cosine x plus 2. Now for these ones, we've got the extra challenge of having an inside coefficient with our x value here. So the whole idea is cosine naturally repeats when the inside of cosine becomes a full circle, 2 pi. So in order to figure out when this cosine graph will start to repeat, or when it will finish one cycle, when it will start to repeat, what we need to do is we need to figure out when will the inside be 2 pi. Because that will be when the inside hits a full circle. So the inside must equal 2 pi at the end of the first period. And now all we have to do is solve for this x value. So we multiply by 10 on both sides. That gives us x equals 20 pi. So it looks like rather than having x be 2 pi, in order to make the inside be 2 pi, one full circle, or one full cycle, we need to plug in 20 pi for x. So our graph is going to look like this. We'll have one period of this will be at 20 pi. The halfway mark will be 10 pi. The quarter mark will be 5 pi, and the 3/4 mark will be 15 pi. Beginning is still 0. And now to graph it, we've got cosine, so it will start off at its maximum value, height of 1, 2, 3, go down to the midline, which hasn't been shifted in this case, down to -3, up to the midline, and returning to its maximum value of 3. Now it says graph the one period of the wave whose equation is y equals -6 sine pi over 6x. Make sure to label all key values. So we'll approach this one the same way. To complete a full cycle, the inside of sine has to equal 2 pi. So basically we need to have pi over 6x equal to 2 pi. Solving this for x gives us pi x equals 12 pi. Finally divide by pi on both sides gives us x equals 12. So to complete a full period, x has to have a value of 12, because that will make the inside 2 pi. So laying out our values, one full cycle will be 12, which means the halfway point is 6, the quarter mark is 3, and the 3/4 mark is 9. And to graph our sine function, we have an amplitude of -6, which means we'll be starting at the midline, and rather than go up as we usually do, we will be going down first, all the way to -6, up to the midline. Since we're doing everything in reverse, since there was a negative sign here, now it will hit the maximum, and then return to the midline at 12. So this is our graph of y equals -6 sine pi over 6x. I hope you guys found this video helpful, and we'll see you guys in class tomorrow.